Okay, Assalamualaikum warahmatullahi wabarakatuh. So today inshallah you will learn about electric charge and field, chapter 1. Okay, and for this chapter, okay, before we'll go further, let us see our surrounding, which let's say when you go to the petrol station, you can see these four signs, okay, and I believe some of you didn't notice that this sign below have relation with what we will learn today about the electric shock, okay, or electric charge. Okay, so after this, when you go to the petrol station, please alert with the sign. Okay, and this is a natural phenomena where happen at many locations when there is a heavy rain, thunder. Okay, you can see thunder here, and very clear thunder, and this has relation with the electric field, that the topic that we will learn today. Okay, so the scope of study, first of all you will learn about static electricity, then electric charge and the conservation. Then after that you will learn about inductors, conductors, and also the induced charge, Coulomb's law, electric field, field lines, calculation of electric field, electric flux, and Gauss law. Right? So what is the static electricity? Okay, sorry. So for the static electricity, it's a stationary electric charge that is built up on the surface of a material. So the keyword here, okay, right, okay. The keyword here is that when we talk about static electricity, okay, so for static, so the keyword here is the stationary, okay, stationary. So what's stationary? The electric charge, okay. So the electric charge is being built up, okay, built up on the surface of a material. Let's say we have a surface of a material, and the electric charge positive, negative, positive, negative, positive, negative, positive is on the surface of a material. So that is the static electricity, right? So this is one of the thing, okay. The one of the example. So this boy rub the balloon with his hair, and uh, he found out that the balloon can attract the peppers, okay, uh, that he has cut before. So this balloon and this pepper got interaction, or we call this as a static uh, got a static electricity, okay, because of the friction here, right? So let us go to the fundamental of the charge, okay. For charge, when the charge is neutral, it means that the quantity of electrons is equal to protons. When the charge being called as negative charge, it means that the electrons is more than protons. And when we call a charge as a positive charge, it means that the protons is more than electrons. So the conservation, okay, the law of conservation of electric charge state that the net amount of electric charge, okay, the net amount of electric charge produced in any process is zero. Okay, is zero. So the net amount, okay, the sum of the net amount in and out of electric charge produced in any process is zero. It means that uh, the electric charge is being conserved. Okay, so for insulators, okay, insulators is the material that do not allow, okay, that do not allow electrons to flow through them easily. Okay, insulators. So what is the examples? What are the examples? Glass, plastic, ceramic. Okay, and rubber. Then we have a wood, a fabric, wool, core, and paper. Okay, so all these things are insulators, which do not allow electrons to flow through them easily. Okay, so conductors. Okay, conductors is a material that allow electrons, okay, to flow through them easily. Okay, and electric charge can move freely in response to an electric force. For example, aluminium, okay, steel, and gold. Right. So next one is about induced charge. Okay, we can induce charge by charging by three types of charging. The first one is charging by conduction. For charging by conduction, involves the direct contact. Okay, when we talk about conduction, charging by conduction, it must have direct contact. Okay, direct contact. Okay, of a charged object to a neutral object. Okay, for example, here we have example. Let's say we have a positively charged rod. Okay, mainly this rod is positive because it only have few electrons. Okay, and then we have one neutral metal here. So if we move the charge rod and to touch the neutral metal, what will happen is that the electron flow will flow. Okay, the electron will flow between these two materials, and for this neutral metal we can see that the electrons, okay, will flow to the rod because being attract the electron being attracted to the positive charge rod. So then the then after that uh, when we have separate the materials, we will find out that this metal, okay, this metal will become positive charge, and this rod will become less positive. Okay, okay? If we compare with the previous or the initial one, okay. So because of the electrons that flow through the charge rod, this rod will become less positively charged rod. Okay. The next steps to charge, okay, is charging by induction. Okay, charging by induction is when we charge an object with another without direct contact. Okay, without direct contact. Okay, for example, let's say we have a neutral metal sphere. Okay, a neutral metal sphere. Then we move the rod, the negatively charged rod, closer to the metal sphere. Okay, what will happen is that this randomly distributed charge inside the metal sphere will align themselves according to the position of the rod. Let's say this rod is negatively charged. It means that this part of the metal sphere will be crowded by or will be lined by positively charged, positive charge. Okay, positive charges here. Well, the negative charge will, of course, will go go far away from the rod. And then if we connect the rod or we grounded the rod, okay, we put a grounded wire here and we grounded the rod. What will happen is that the negative charge, the electron, will move up, okay, from the rod, from the metal sphere, and this metal sphere will become positively charged metal sphere, right? And lastly, okay, oh, this should be charging, charging. Okay, charging by friction. Okay, so for charging by friction, okay, example is charging by friction is rubbing a balloon against your hair, so the electrons will move from your hair to the balloon, so the balloon will become negative, and your hair will become positive charge, has more positive charge. Okay, So means that your hair and the balloon will have different charges. Okay. Bear in mind that by rubbing the materials, it does not create the electric charges, but it just transfer. Okay, it just transfer the electrons, okay, from one material to the other. This is the situation that you found out in the beginning of this slide, where I show you the sign of electric shock at the pump station. Okay, the thing that you need to alert. Okay, so when we drive, okay, when we drive a car, for example, we will have a friction between our body with the car seat. Okay, and of course there will be a movement of electrons here. So our neutral body will not become neutral again. Will not become neutral because the negative charge will flow to the seat. So we will have a unbalanced or imbalanced charges. So when we pump in the petrol, okay, uh, we must ensure that, okay, there is no static electricity, okay, uh, that become a spark, okay, and when this spark happen, uh, it will ignite the gas fumes and cause a cause a fire here. Okay, so to avoid this imbalance charges in our body before we pump the petrol to our car, we must ensure this safety, this thing. Okay, the first one is do not re-enter the vehicle while pumping the petrol. Second one, uh, please make sure that you touch something metal like the side of your car before handling the nozzle. Okay, you can touch your car before before you handle the nozzle. Okay, and some of the petrol station got uh, a specific place to touch. Okay, that they create a specific place for you to touch your hand there, so that the imbalance charge in your hand will flow to the metal, or to the to that place, and your body will become balanced. Okay, or your charge inside your body become balanced, so they will be not no they will avoid it will avoid the fire to happen. Okay, and it will increase the safety of our safety of the petrol station and ourselves. Okay, right.